Now coming on to the basic components used in the circuit. The first one is the ATmega 328 with the bootloader kit. The second basic component is the GSM module SIM 300 version 7.03. The third basic component used by us is a GPS module by Fast Tracks version UP501, and the other components used in the circuit are a buzzer and an LED. Detail what constitutes our sensor equipment. So as we see that this is a Hall sensor. It has 3 pins. First pin is the VCC, third is the ground, and the second is the output. So as the magnet is brought near to the sensor, the output goes high. Per se, this sensor is triggered by the south pole. Then as the south pole is brought near to the sensor, the output increases. So how does this sensor helps us to calculate the water flow rate? So now as we see that this is a perforated disc with blades at the edges. When the water hits the blade, the disc rotates about the axis. So as we see that there is a magnet very near to the disc. So when the Hall sensors which are embedded comes in the vicinity of the sensor, it gives a high output which is read as an impulse upon the microcontroller. And so the impulse rate gives us an output proportional to the water flow rate. And that's how we calculate the water flow in the pipe. To the demo, the bucket simulates the reservoir and the pump simulates the water flow. The water from the 3 pumps is collectively aggregated into a pipe of diameter 1.5 inch and 2 meters length. On the other end of the pipe, we have a container which collects the water. The water in the process passes through a sensory equipment which works on the principle of Hall's effect associated with an encoder. The output of a sensor goes on to the microcontroller ATmega 328. The other components which are present in the assembly are the GSM module, the buzzer and the LED system, and a GPS module. The output of the microcontroller is mapped onto MATLAB, which for now shows a zero flow rate. To simulate a real-time water flow, we'll start the pumps, and as shown in the graph, the rate is stabilized at around 800 to 900 liters per hour. The data is sampled for every 0.1 second, and then the software analyzes the differential flow over a 1 second window, and on detecting a discrepancy between the readings triggers the buzzer and the LED, and the message is sent via the GSM module along with the GPS location to the concerned authority. As shown on the mobile phone, a message is seen which reads leakage detected along with the latitude and the longitude data of the leak. Thus, when the system is implemented on a real-time pipeline on large scale, the leakage along with its exact location can be located on the pipeline network. Thank you.